Problem number 8, they gave us some values for t, and they want us to plug in and figure out what the xy points are based on t. And the numbers they gave us was -3 through to 3. So I have -3, -2, -4, oh, not -4, -1, 0, 1, 2, and 3. Okay? So those are all the values that I have to figure out. Well, to figure that out, to find the x value, I've got to take the square root of these numbers. So if I were to do this one, I would say x is equal to the square root of -3. I can't do that. But the y value, so at this point, that point doesn't exist. And here, if I were to say x equals the square root of -2, I can't do that either. That would be an error. So that point doesn't exist. I mean, I could get the y value, right? So if I were to plug in the y value, I would get 2 times -3 minus 5 here. And here I would get 2 times -2 minus 5 here. And if we were to complete that, it'd be -6. So this would be -11, and this would be -9, right? But the point doesn't really exist. So I guess, well, I shouldn't leave that blank like that. Let's plug it in. We'll say -11 and -9, but I can't take the square root of a negative number. So on this one, when I say x equals -1, again, it's an imaginary number. We're only dealing with real numbers today. And so here I would say 2 times t, which is -1 minus 5, minus 2 minus 5 is -7. Okay? And so when I plug in 0, now finally I can find the square root of 0, which is just 0. And then y is equal to 2, -1 minus 5. Oh, no, wait, times 0. So this is -5. Okay. This would be the square root of 1, which is just 1, and then this one would be 2 times 1 minus 5, which would be -3. Now, the only thing that's, and so if I were to plug in 2, I get the square root of 2, and then 2, that would be -1. This would be the square root of 3, and then 2 times 3 is 6 minus 5 is +1. Okay. Now you could do this on the calculator. It goes a little simpler. You could do it a little faster on the calculator. Let me pull up my calculator here. So to do this on the calculator, the first thing I need to do is put my calculator in parametric mode. And then when I hit my y equals button, you'll notice that I have x equals a number and y equals a number. So I'm just going to plug those in. I'm going to say the square root. And if you're wondering where the t is, it's right here. It's the same button that we use for x. So x equals the square root of t, and then y equals 2 times t minus 5. Now when I look at the table of values, if I scroll up or down, I get all these errors, right? So when t equals -3, I don't get an x value, but my y value is -11. When t equals -2, again I get an error for x, but -9 is defined for y. And so I don't start to get a value for both x and y until t equals 0, because we can only take a square root of a non-negative number. And so since x equals the square root of t. Now how this looks graphically is that it looks like a parabola. Now I'll show you why it looks like a parabola in a second. But the graph is nothing more than these numbers graphed as x, comma, y. Now the values for x and y are dependent upon t, But really, when we graph, we're only dealing with the x and y's that we calculate based on what we plug in for t. And it looks like the right-hand side of a parabola. So now how do I show that relationship? Well, so part A, this is just part A. Part A just wanted us to plug in the table of values. Part B wants us to show the algebraic relationship. In other words, I want y equals some function of x. Okay? Now that's a little more challenging. So what is y? Well, we said that y was equal to 2t minus 5. And then we also mentioned that x is equal to the square root of t. Now the trick is to make this x somehow plug into this t. The way that we do that is we got to get t by itself. So to undo the square root, I take a square here, and whatever I do on one side of the equal sign, I do on the other. So I get that x squared is actually equal to t. So since t is equal to x squared, wherever there's a t, I'm just going to plug in x squared. So on my very next line, I would say y is equal to 2 times x squared minus 5. And that's where the parabola thing is. So that's part B. That's that parabola thing. And so just to verify that, so you guys know that I'm not making that up, this is the graph of my parametric equation. However, if I go in here and I switch to function mode and I graph 2x squared minus 5, I will get a parabola, but I'll get the full parabola. The reason that I only get half, so let's go back to the other mode. The only reason that I get the right half of the graph is because t is restricted. Well, why is t restricted? Because I can't take the negative square root, or square root of a negative number. So it's not, well, the domain of t is restricted on the function x. So really x is restricted. Okay? But they're the same thing. Well, that was part B. Part C says graph the relationship in the xy plane. Well, basically what I would do is I would just graph these points. So if I were to come in here and I would start at 0, negative 5, 1, 2, 3, 4, 5. That would be a point on the line. And then 1 comma negative 3. And then the square root of 2, which is 1.4. That would be 1. The square root of 3 will be about 1.73. And so this is the point 0 comma negative 5. This is the point 1 comma negative 3. This is the point square root 2 comma negative 1. And this is the point the square root of 3 comma 1. And so those graph, that's basically the graph. That's my parabola. Where this is x and this is y. Consequently, this occurs when t equals 0. This occurs when t equals 1. This one occurs when t equals 2. And this occurs when t equals 3. So that's the relationship between all three. Okay.